Hello. So in this section, we're moving away from simultaneous equations. Now we're going to look at inequalities, okay? And I guess the first set of inequalities are linear ones. So these are inequalities that look like x less than 2, x greater than equal to 5, and so on, right? So they're linear, so obviously it's just linear in terms of x. There's no powers, so no x squared, no anything like that. So they're fairly simple, right? And we're going to look at solving them and interpreting them. And that's essentially it, right? So this should just be from GCSE. However, there is one other section called set notation, which you would not have seen, which does come up. It can be quite tricky. So this isn't an entirely useless video, right? There is some new content if you stick with it towards the end. But anyway, linear inequalities then. So as we're really going back to basics, brief recap. If we have x less than or equal to 2, for example, that's saying x less than 2, okay? If we had, say, x greater than 6, this symbol, that means x greater than 6. So what you need to understand is what these sort of crocodile sort of signs look like, right? So I hear some people talk about it like crocodile clips, something like that. So if it's facing left, then it's less than. If it's facing right, then it's greater than, right? You can think of this as like a number line, right? So think about the x-axis here. Obviously, the further along you go, the more positive you get. So it has to be a greater than if it's to the right. If it's to the left, then obviously vice versa. You get more negative, so you get a lower answer. So it'd be less than, okay? So that's how you can think of it in terms of like the direction of like a number line or the x-axis to think about the direction. Hopefully, you are very well acquainted with these signs. And also, you don't have to be greater than exactly. You could have something like this, where you have a greater than or equal to. We denote an equal to, so x greater than or equal to 10. Um, And we have this extra line here underneath the crocodile clip, if you will, to denote it can be equal to 10. So it can be any value above 10, but it can be 10 itself as well. Okay. So that's essentially just like a refresher. And also with number lines, we can represent these graphically on the number line. So let's just pick the middle one, x greater than 6. So again, the number line of values for x. Then say we have 6, right? Then and we want any value that's strictly greater than or over 6, right? So we denote that by this, okay? So we have a circle that starts at 6, and then you have an arrow or line that goes outwards, basically forever, right, towards infinity, because it can be any number as long as it's just above 6. But if it's only greater than, we call this a strict inequality. Um, because it cannot be equal to. It's quite strict, right? Um, so when it's a strict inequality, i.e., when it's not equal to, like this one isn't a strict inequality because it can be equal to 10, then it has the circle is not filled in. Whereas with this other example to the right, if we have 10 here, then we have a circle at 10, but it's filled in, right? Notice I filled it in. And again, it goes and extends out to the right because it can be anything over 10. So again, I guess with the last example, we can also go the other way if it's less than. So if we have 2 here, then a circle at 2, because and then any value less than that, okay? And again, it's not filled in because it's strictly less than 2. Okay, so that's just a good refresher of inequalities and what they mean. So yeah, now let's have a look at the examples where you solve them. And so let's have a look at this part A. We have 5x plus 9 is greater than or equal to x plus 20. And so the whole idea with solving inequalities, they work in exactly the same way with solving equations. So you can add or subtract a number to both sides. You can multiply or divide by a number to both sides. However, the only difference is when you divide or multiply by negative, i.e., you flip the sign on both sides, you have to reverse the direction of the inequality. We'll go over examples like that as we go on. Anyway, so we need to solve this. So what that means is you need to get x on its own greater than or equal to, or less than or equal to, or greater than or less than some number, right? So basically, it's like x has to be equal to a number, right? X is some number k, but instead of equal to, it has to be one of these four signs. So greater than, equal to, less than, equal to. Anyway, so we need to solve just get x, right? So first of all, like with any equation, you want to get x on its own. So let's take away the x to both sides. So you're left with 5x minus x is 4x plus 9 is greater than or equal to 20. Then we want to get rid of this 9, so minus 9 to both sides. Then we get 4x is less greater than or equal to 11. Cool. But then x, if you divide by 4, is just simply greater than or equal to 11 over 4. Okay. Cool. That's part A. Let's have a look at part B. Uh, then it's saying 12 minus 3x is less than 27. Okay, so I want x on its own. So minus 3x, if I subtract 12 to both sides, I get 27 minus 12, which should be 15. Cool. Okay. Okay, but then I want to divide by minus 3, right? To get just x on its own. However, we're divided by a negative number. So we have x and 5. Okay, cool. That a minus 5, as expected. But you need to reverse the sign. So if it's less than, then it needs to become a greater than instead. So this is your solution, x greater than minus 5. And there we are. Cool. So that's the only caveat, right? So we treat it like an equation, except from the case when you divide uh, or flip the sign of both sides of the equation. So if you divide by negative or times, then you have to flip the sign like we saw there. Cool. Okay, let's have a look at part C then. We have 3 lots of x minus 5 greater than 5 minus 2 lots of x minus 8. Okay. Well, firstly, just expand the bracket. So 3x minus 15 greater than 5 minus 2x, and minus 2 times minus 8 is plus 16. Okay, cool. Then I want to get the x's to one side, so I can just probably be best to add to 2x's. Then I get 5x minus 15 is greater than 5. Well, 5 plus 16 will be 21, so we can simplify that bit. Okay, but then I can just get 5x on its own by adding 15, so I get 36. Then x is greater than 36 over 5, which I believe simplifies, does it? Uh, no, it doesn't. That's really it. Okay, that's the final answer then. X greater than 36 over 5. Cool. There we are. So that's hopefully see nothing too troublesome there. Just solve it like an equation, right? Okay, cool. Okay, we can extend this then to actually solve multiple inequalities. So we can combine two inequalities together if we can. So let's have a look what that means. So here you recognise we need to solve two different inequalities in the question. So part A, firstly, we need to solve firstly 3x minus 5 is less than x plus 8, and 5x is greater than 5x is greater than x minus 8. When you have multiple inequalities, you solve them one by one, right? And then we go from there. So we can solve this first one. So again, I'll get rid of the x here to both sides. So then you have 2x minus 5 is less than 8. Then I'm going to add 5 to both sides. So 2x would be less than 13. Then x will be less than 13 over 2. Cool. So that's one of them. That's solved. Uh, okay, now I need to solve the other bit, the other one. So we have 5x greater than x minus 8. Well, then I can move the x here to there to get 4x. If I subtract x greater than minus 8, then x is greater than minus 2. Cool. So we've got these two inequalities. However, we can combine them because think about what this is saying. Okay, this is saying x needs to be greater than -2 here, but also x has to be less than 13/2. What we can do in that case is we can actually merge them together as one singular inequality. Well, -2 is the lower bound, if you will, so x has to be above that. So -2 is less than x, but then x has to be less than 13/2. That 13/2 is like the upper bound, okay? Therefore, we can then combine that as one inequality, and that'll be your answer. Okay, cool. There we are. Alternatively, you can. This is where the number line stuff will help us. If you are really struggling to visualize how to combine two inequalities, well, you can draw them both on the number line, right? So, firstly, our values are -2 and 13/2, which should be about there. Well, firstly, x has to be less than 13/2, so it's going to be an arrow that way, right? Then x has to also be greater than -2, so draw a circle there, and this time has to go upwards. And then what you want to do is basically the overlap is your solution, right? So it'd be there and there. So the region between -2 and 13/2 is your answer, right? For x, so all the values of x in between. Remember, so these two, where the two lines that overlap each other, which means it's a solution to both inequalities. But obviously, because the circles are not filled in, it has to be strictly less than. Okay. So that's alternatively how you can visualize how you get the answer. Okay, cool. Part B then. Again, likewise, it's saying to solve x minus 5 is greater than 1 minus x, and we need to solve some other inequalities. Let's solve the first one. Do uh, step by step. Do inequality by inequality. Okay, so I'm going to add x to both sides firstly. So 2x minus 5 is greater than 1. Then 2x will be greater than 6. If you add the 5, then x will be greater than 3. Cool. Likewise, then we're going to solve this inequality. 15 minus 3x is greater than 5 plus 2x. Hope you have room here. Well, I'm going to add the 3x to both sides. So 15 be greater than 5 plus 5x. Then I'm going to move to 5. So 10 will be greater than 5x. What I'm going to do here is, at this point, that's saying 10 has to be greater than 5x, which also means 5x has to be less than 10. What you can do is, to help you visualize the inequality, I always like my variables for x's to be on the left side, uh, but not on the right side of the inequality like this. What you can do is you can flip it the other way around. So 5x instead is exactly the same, saying 5x is less than 10. Okay, I can reverse the ordering, and it means the same thing, right? So this is saying 10 has to be greater than 5x, so 10 is above 5x. This is saying 5x is less than 10. They're exactly the same thing, so I can reverse it to make it easier to visualize. So 5x less than 10, that means x will be less than 2. Okay. And again, okay. So, so let's have a think what they're saying. X has to be above 3, but then x has to be less than 2. Okay. But, so that kind of happened really. So you have a number, so think about the number line. What would that look like? X, if we have 3 here and 2 there, x is above 3 and x has to be less than 2. There's no overlap, so there's no solution. However, however, that's where these command words come into play. Notice it says and in part A, so that means we have to combine them. So x has to satisfy both inequalities. If it says and, that means x has to be a solution to both inequalities, which means we have to combine them. However, in part B it says or. Okay, so that means we can only we only, x only has to be a solution to at least one of the inequalities. Okay, so we do not have to combine them in this case because it says or. Okay, that's the key command word. When it says or, we only need to consider if the inequality separately. And there we are. So it's literally our solution: x greater than 3 or x less than 2. Okay, we can't combine them in any way because obviously there's no overlap. We just seen that with the number line. So that was it, right? So x can be above 3 or x is less than 2. Okay, and that's your solution. Okay, part C. I'm going to need to make room here. I'll do it here. Let me get rid of the number line. Part C. We have 4x plus 7 greater than 3, first of all. So 4x would be, great. Well, take away 7. 3 take away 7 is minus 4. Then x would be greater than minus 1. Cool. Okay, then the other inequality is 17 is less than 11 plus 2x. Then I'm going to take the 11 to both sides, so that'd be 6 less than 2x. Again, I'm going to reverse it because I don't like the x on the right. I find it a lot easier to work when x is on the left. So this is same saying 2x is greater than 6 if I just reverse the ordering, reverse the sign of stuff, the direction. So 2x is greater than 6, then that means x is greater than 3. Okay, so this time it says and, so it needs to be satisfying both inequalities here and here. Think about what this is saying then. X is greater than minus 1. X has to be above minus 1, but x also has to be above 3. But really, the overall solution is just x greater than 3. Because if x greater than 3, then really x is also greater than minus 1. So that's the stricter of the two inequalities, right? So we take the strictest solution which satisfies both of them. Again, you could visualize this on the number line to say, well, if we have plot the points minus 1 and 3, which are key values, right? Minus 1 first, so x has to be above minus 1. Then x has to also be above 3. Well, the overlap is going to be here, right? So starting at 3. So x is above 3 is the solution there. Okay, cool. But I think it is a lot easier. And I would advise getting comfortable with trying to avoid the number line and just think about actually what the statement's saying, which is why I went over at the start. So x greater than minus 1, interpret it in words, right? And then x greater than 3. Well, really, you take x greater than 3, right? Because then it's automatically also greater than minus 1. I don't know. Again, if you really are struggling using the number line, but to try and think about what it means in words. And yeah, so that's how we can combine it, right? Several inequalities together to get an overall solution. Okay, paying attention to these command words, and these are going to be very important in a second as well. These command words and or when we're linking several inequalities together. Okay, so that's the overall thing. But now we're going to look at something called set notation. And the textbook doesn't go over it really. So I'm going to dedicate this section. The rest of this section will be for set notation. Obviously linked to linear inequalities. But now we're going to look at the set notation. Okay, so I think this is a bit easier done if we looked at probability section because you will look at what we're about to say. However, if you just from G to C, you should also remember when you looked at Venn diagrams, right? So something like this. Okay. Well, so you should remember we have two sets or two lists. Say we call it A and B, and then we have this box outside that represents everything else that isn't in A or B. Okay. Now, um, now you should also remember you should be familiar with this notation. This U shape, which means union, which also means or, okay, in simple terms. And also this symbol, which means intersection, which means and, right? As you, so or and, as you just saw in the previous question, those were the command words, right? So this is where it's going to come into play, these symbols, okay? So, uh, if you were to say A or B, well, I've just said it there, A or B, right, this symbol U, that means anything that's in A or in B. But it could also be A or B, right? Because why it's sent. If it's an A and B, then it's in A or B, right? So it's the two circles, right? So that's that. Then if I get rid of the shading, if instead this time um, I have this symbol B, which means A intersection B. It means A and B, so that's when it has to be in both lists. Okay. Okay. And that's what that means, right? So that's just a brief overview. Those symbols shouldn't be too unfamiliar because again, you looked at it when you looked at Venn diagrams at GCSE. these U and the N shape. I like remembering the order, what they mean, because N has a distinctive N sound, so and has a N, has a quite distinctive N sound, pronunciation to it, right? Like with that, this looks like an N, right? So N and I guess if you can really extend it to or as well, like or has like a sort of U shape, a U sound, sorry. So it looked like the U shape because U or I don't know. They look for me. They sound vaguely similar phonetically. I don't know. That's how you can sort of remember what each of these two shapes mean. Okay, so hopefully you're familiar with that shape's mean. But now we're going to look at sets. So I did also describe that A, B are sets. What sets are mathematically? They're just lists, right? So, for example, this list here, we denote a list by this curly bracket here. I'm not the best curly bracket drawer, uh, but we denote a list by this curly bracket, and then we put our entries in. So, say if I had this list 1, 2, 3. These are the lists of the first three positive whole numbers, right? The first three natural numbers, right? Uh, if I had this list, um, if I call it summer, winter, uh, spring, oh, autumn, then these are the list of the seasons of the year, right? The 4 seasons of the year. It doesn't have to be mathematical, but that's the idea of a list, right? A set is basically a fancy name for a list where we have these curly brackets, and then what we put into this is our entries, right? What we call elements, actually. Um, so again, this is fancy mathematical language. So a list is essentially a curly bracket, and what we put in the list are elements or entries, but we call them elements mathematically. Okay, that's all it is, right? That's sets, pretty much as it is, right? Nothing more to that. So just get used to the curly bracket. Okay, okay, okay. What we're then going to extend this to is solutions, right, of inequalities. Okay, let's have a look at this inequality here, x greater than 2. Okay, we can represent that as a number line, as we saw last time, earlier, right? Even so, we have 2 here. Again, we can represent that as a not as a hollow, not filled in circle, and it goes out like that to infinity. Um, but there is a more mathematically precise way of phrasing this, right? Using sets, our set language that we just discussed. And how this works is a curly bracket, which represents we're going to have a list, so the values of x. And what so we're going to create a list or set technically, and then we're going to say x dot dot x greater than 2. Okay, and then we close the list by adding a closing curly bracket, although it's not very curly. Uh, and that's what that means. So this is saying a set of numbers of x, right? In particular, what set of numbers of x? Well, what this is saying is the curly bracket, which means a set, uh, and we say this as a set of values of x such that x greater than 2. Okay, that is what this whole thing means in English, right? So the set, again, the set of values is referring to the curly brackets, and the values of x, which is what we define is x here, such that is these colons here. That's what that means, right? So x such that x is greater than 2. Well, x greater than 2 is there, right? So that's nothing new there, and that's all it means, right? So you basically all you need to know is we can describe in English this sentence. So the set of values of x such that x greater than 2, we can convert that into this set here, this sort of notation here. So a curly bracket, so we want the set of values of x into the curly bracket, x dot dot x greater than 2. And so this is the mathematically precise way of describing a set of values for x, right? An inequality, okay? And they will expect you in certain questions to say, give your answer in set notation. That means this. So write your answer as a set, okay? And don't just leave it in this form here. But yeah. Um, and the reason they do that, it seems a bit weird in the A level, just randomly. But when you do go, if you are going to university study in a mathematical subject, you will come across sets all the time. Okay, so it's kind of their way of trying to introduce that to the A level now, because it is quite important if you study maths higher up. Anyway, cool. So again, as another example, x less than equal to 5. We can write that as, again, the set of values x such that less than equal to 5, right? And if you really want to, you can just memorize it as saying a curly bracket x dot dot, and then you put your inequality in, and then you close it with the other curly bracket. So that's all you really need to learn is this bit here. And it means a set of values of x such that x less than equal to 5, okay? So describing a range of values of x, okay? A set of values, remember, just a collection of values of x, right? So it's like a list of values of x. Anyway, the last thing, and this is where it's going to come into looking at these two symbols here, is when we have an instance of multiple inequalities. This is where this steps up. So if we then wanted to say x was can we combine this? Yes, x greater than 2 and x less than equal to 5. Okay. Um, so we're combining these two examples here. Well, what you from the last exercise, should realise that we can say that this means we can combine this together. Say 2 has to be less than x, has to be less than equal to 5. So x has to be greater than 2, but x also has to be less than or equal to 5, which gets us this. We can say then the set of values of x such that 2 is less than x, less than or equal to 5, right? However, what we can also split this into two separate sets or two separate brackets to say this set x again, and we can write this out instead. So x greater than 2 and x less than or equal to 5. So you can split the inequalities up to say x greater than 2 and, but how do we write and? Remember, it's this weird shape here, right? Which means and. So in set notation, so using the language of sets, instead of saying and, we use a symbol and the set of values of x such that x is less than or equal to 5. Okay, so they're both exactly the same, but that you might see it written in this form, but don't freak out. That's what that means, right? So we can combine multiple inequalities using these two symbols here, if we ever do so. Last example, and we're going to look at loads of examples in a minute with this in practice to really reinforce this. I think it is quite challenging, especially at the start when you're trying to understand this. But the last example is actually x less than 2 or x is greater than 3, okay, as an example. I think that's one of the early examples, wasn't it? What you cannot say is, well, we could say the values of x such as x less than 2 or x greater than 3. We cannot say that because ideally you shouldn't have any words in your sets, right? There should be no words. It should all just be like symbols, mathematical symbols, right? Also saying this wouldn't be correct either, actually. The reason is with sets, you should only have a single inequality in your sets, right? When you start splitting up to get two different inequalities like this, uh, that's wrong. A set should only have one particular inequality in. This is fine in this example because it still is kind of one inequality, right? We've got it's sandwiched between two values, so 2 less than x less than equal to 5, but it's one inequality because we combined it into one. That's okay, but we combine these two into one, and we can't just say or here. We have to then split this up into two different sets, which each have contained one of the inequalities. So instead, we're going to say the set of values of x, such as x less than 2, or, and then the or is outside, or the other set of values of x, such that x is greater than 3, okay? So that's how we would describe that in set notation. And remember, or, then we say this U shape, which means or, okay? Which means union, which means or, okay? Okay, there we are. So that's essentially it. So the main idea is you know how to write the curly brackets of x such that, and then you give it inequality. So in this example, this part is saying the set of values of x such that x is greater than 2, okay? And when you combine inequalities, you might need to use these symbols here, which means and or, okay? And the other idea is that you can't have you can't have two inequalities in one bracket. If in this case, like the last example, again, you need to split it up if you have two different inequalities. Okay, if you can combine it to one inequality, then that's still one inequality, like that example, like a circle. But when you have to then physically split it up into two, like this, then you need to split it up into two different sets. Anyway, okay. I'm going to get rid of all that now to make room, but we're going to look at a bunch of examples now, asking us to give answers in set notation to really drum this in, okay? To look at in an exam scenario, um, what you'd expect it to do. Um, but yeah, so let me get rid of all this. Duh, duh, duh. Okay, I'm going to leave that there now. I'm going to do my answer here then. So, part A, so it's asking us to use set notation to describe this set of values of x. So, firstly, 3 so x minus 2 is greater than x minus 4. Notice that it's two inequalities. So, again, like the last example, to solve them one by one and then go from there. So, let's expand the bracket. So, 3x minus 6 is greater than x minus 4. Then we take away the x, so we can say 2x, and then I'm going to add the 6 to both sides to be greater than 2. That means x has to be greater than 1. Likewise, we need to solve 4x plus 12 is greater than 2x plus 17. Then we take away 2x to get 2x. Then I take away the 12 to both sides as well to be greater than 5. Then that means x has to be greater than 5 over 2. Okay, okay, this time it's saying and. So that means it has to be both inequalities. So we need to combine them together. Okay. Now think about this. If x has to be greater than 1 and x has to be greater than 5 over 2, which is 2.5, well, the bigger one is 2.5. So all in all, these just combine to get x greater than 5 over 2. Okay. There we are. So then as a set then, so that is equal to, a set notation is the set of values of x such that x greater than 5 over 2. There we are. Great. Okay, cool. Part B then. 2x minus 5 is less than x minus 1. So solve that one first. So take away the x both sides to get x. Then I'm going to add 5 to get less than 4. Uh, cool. Then we have 7 lots of x plus 1 is greater than 23 minus x. So then let's expand this. So 7x plus 7 is greater than 23 minus x. Then I'm going to add the x both sides to get 8x, and then I'm going to move the 7 to the other side to get 23 greater than 23 minus 7 is 16, right? But then that means x has to be greater than 2. Okay, so that then, okay, you're saying and again, so it has to be a solution to both inequalities. So x has to be less than 4, but x has to be above 2. So 2 is the lower bound, so the lower value of x. So 2 has to be less than x, but x has to be less than 4. Okay. So we can write that as one inequality, and therefore we can use set notation to say the values of x such that 2 is less than x, less than 4. Now we don't need to split this up because it's one singular inequality, okay? We have two inequalities, sure, but obviously they're both, again, combined as one whole inequality, right? Anyway, okay, for part C then, it's saying 2x minus 3 is greater than 2. So let's solve that firstly. So 2x is greater than 5 if I move to 3. So x is greater than 5 over 2. Then the other inequality is 3 lots of x plus 2 is less than 12 plus x. So again, let's expand it first to get 3x plus 6 is less than 12 plus x. Then I'm going to move this x to the other side, take away x to both sides to get 2x. Then I'm going to take away 6 to both sides to then get less than 6. That means x is less than 3. Cool. So those are the inequalities. But notice it's saying then and again, so it needs to be combined inequalities. So it has to be both of them. Okay, so it needs to satisfy both inequalities. So then think about it again. Use words to help. So x has this one is saying x has to be above 5 over 2, which is 2.5. Okay. So x has to be greater than 2.5, but then x has to be less than 3. So we can merge them together to then get 5 over 2, which is the lower bound for x's smallest value, which is, and then x has to be less than 3. Okay. So x is above 5 over 2, but x is also less than 3. Okay. Okay, then as a set, we can simply say then say that the set of values of x which is at 5 over 2 is less than x, which is less than 3. Okay, and that's a singular inequality overall, so that would be fine. So cool, that's a set of values of x. There we are, so part D. And hopefully you start to recognise the pattern now for these sort of set notations. Part D, we have 15 minus x is firstly less than 2 of 11 minus x. Yeah, there we are. 15 minus x less than 2 lots of 11 minus. Yep, let's expand this. So 15 minus x less than 22 minus 2x. Then I'm going to add x to both, 2x to both sides. So I'm going to have x and then plus 15, but I'm going to move the 15 to the other side to then get less than 7. And that's it, right? Then the other inequality is 5 lots of 3x minus 1. I'm going to do that here. Is less than greater than 12x plus 19. There we are. Let's back that a bit neater. There we are, 12x plus 19. So I'm going to first expand the bracket, so we get 15x minus 5 is greater than 12x plus 19. Then I'm going to take away 12x to both sides with 3x, then add 5 to both sides, with greater than 24. That means x has to be greater than 8. Okay, if we divide by 3. So that's our two solutions, right? X greater less than 7, x greater than 8. However, it's saying it has to be and again. So it has to be a solution to both inequalities. So we need to sort of combine them. Well, then this is saying x is greater than 8, but then x also has to be less than 7, right? It has to be and. So x less than 7 and x greater than 8. That actually cannot happen, can it? Because it's saying x has to be bigger than 8, but also x has to be less than 7. Right, you can't have it's either one or the other, but you can't have both. Again, visualize the number line then. If we have 8 and 7, x is greater than 8, simultaneously x has to be less than 7. That cannot happen. There's no overlap. Therefore, there is no solution. Okay, so that is literally it. Therefore, no solution here because there are no values of x where it can be simultaneously bigger than 8 and less than 7. Okay, and we can't write the set notation. There is a fancy way we can call it's something called the empty set. Okay, but I'm not going to go into that. It looks like that. That basically means it's simple. There's no values of x basically. Um, but I'm not going to get into that now. You might see that crop around, but I'm not going to get into that. Part A, so you don't have to write in set notation. There's no solution. Anyway, part A, this time we firstly have 3x plus 8 is less than or equal to 20. Then 3x, if we move the 8, it's going to be less than 12. That means x is less than or equal to 4. Cool. Also, we have 2 lots of 3x minus 7 is greater than or equal to x plus 6. Then I'll expand the bracket to get 6x minus 14 is greater than or equal to x plus 6. Then I'm going to move the x here to the other side, so take away x to get 5x, and then I'm going to add the 14 to get greater than or equal to 20. That means x is greater than or equal to 4. Okay, is it, and it's saying and again. There we are. Yeah, pi and. So it has to be a solution to both inequalities, so we need to combine both of them. Look at the overlap. Okay, so this is saying x has to be less than or equal to 4, but also x has to be greater than or equal to 4. Well, the only overlap is x equal to 4, isn't it? Again, think about what the number line would be if you're struggling. So 4, so it has to be equal to 4 or more, but also equal to 4 or less. Well, the only overlap is actually a singular point 4, okay? Which then means that the only solution is x equal to 4, okay? Because if x has to be less than or equal to 4, x bigger than or equal to 4, and both. So I'm going to say x less than or equal to 4, and remember, the only thing that fits into both of these is equal to 4, right? So there we are, and then as a set, we can write this as a set. It's the set of values of x such that simply x equals 4, okay? There we are. Um, there we are. I'm going to get rid of this number line now, make room, but now we can look at the next question, F. So F now is saying 5x plus 3 is less than 9. Cool. Okay. 5x plus 3 is less than 9. If you solve that, 5x is less than 6. X is less than 6 over 5. Cool. Yes, okay. And then the other one is 5 lots of 2x plus 1 was greater than 27. So let's expand that bracket. You get 10x plus 5 is greater than 27. Then 10x, if we move 5 to the other side, be 22. X is greater than 22 over 10, which simplifies to 11 over 5, okay. And so 11 over 5 is, well, you don't need to know, but it's 2.2, okay. Anyway, so this is saying, well, hang on, let's check. It's saying it says or this time. Okay, there we are. So it has to be either or. So it has to be one or the other. Okay, no, one or the other. But it doesn't have to be both, but it has to be at least one of them. So this is x less than 5 over 6, or x is less than 11 over x greater than 11 over 5. Okay, so it doesn't have to be both. We could combine them anyway. But anyway, it says or. So this means we simply need to write these two inequalities separately. So that's going to be a set of values of x then, such that x is less than 6 over 5. But we do not say or x greater than 11 over 5. Or we can't have two different. We can't have two split up inequalities. Okay. What you need to then do is split this up into two different inequalities. So the set of values of x such that 11 over 5. Okay, because it says or, it has to be this U shape, which means union, which means the or, right? So either or, okay. And yeah, so that is that in set notation. That is a key detail, okay. If we have an or, which means we need to write these as two different inequalities, okay? Um, which means because we have two different inequalities, we need to split them into two different sets. And then we need to see this symbol, which means or, to combine them, okay? So this is saying then the set of values of x such that x is less than 6 over 5, or the set of values of x such that x is greater than 11 over 5. That's saying the same thing pretty much as this, but in a more mathematically precise way. Okay, part F. Then part G, the last one. We have firstly 4 lots of 3x plus 7 less than or equal to 20. So if we solve that, let's expand it. We have 12x plus 28. Less than or equal to 20. Then 12x, we move to 28, be less than minus 8. So then x would be less than or equal to minus 8 over 12, which should be minus 2/3. Okay. So minus 8 over 12 is minus 2/3. I did copy that down. Yes, I copied that down right. Okay, and then we have this other inequality, or 2 lots of 3x minus 5. Has to be greater than or equal to 7 minus 6x over 2. Okay. So firstly, let's expand this. So the left side, so we have 6x minus 10 is greater than or equal to 7 minus 6x over 2. Now, I do not like this fraction, so I'm going to times both sides of the inequality by 2 to get rid of it. So then if we double everything, we get 12x minus 20 greater than or equal to 7 minus 6x. There we are. So that then we can add the 6x, right, to then get 18x. And then I'm going to add the 20 to get greater than or equal to 27. Then x would be greater than or equal to 27 over 18. I don't think that would simplify. Oh, it does 3 over 2. There we are. Okay, so we've got these two inequalities. So x less than or equal to minus 2/3, or, because it's saying or this time, there. So again, so x has been less than or equal to minus 2/3, or x is above or greater than or equal to 3 over 2. So we have to split them up into two different inequalities. So that would be the set of values of x such that x is less than or equal to minus 2/3. And then we have an or, so we need to split this up into this U shape for or. That's what that shape means again. Or the other set of values of x such that x is greater than or equal to 3 over 2. So the key detail there again is that we have two different inequalities, which means I need to split them up because every set, every bracket can only contain one actual inequality. Okay. And there we are. And it says or, so that means I need this U shape, which literally means or. Okay. There we are. So yeah, so that's it's a bunch of examples there with set notation. Hopefully, you start to get a good understanding of set notation, right, and how we write stuff in set notation. Set notation will be for inequalities, okay, in exam questions. So this will be the good place to really understand and how to write down stuff in set notation. So hopefully those examples were useful. I'm going to leave off with a challenge question to really, really test that we understand what set notation is. Okay, let's have a read. A is the set of values of x such that 3x plus 5 is greater than or equal to 2, greater than 2. B is a set of values of x such that x over 2 plus 1 is less than or equal to 3. And C, the set of values of x such that 11 minus 2x is minus 1. Then it's say, given that A and this shape here, which means and, right? B or, which means that shape, that U shape, or the N shape means and, again, if it helps the pronunciation on the N. So A and then bracket B or C is the other set of values of x such that p is less than x less than or equal to q, or the set of values of x such that x is greater than r. We need to find these missing values p, q, and r. Okay, sound like a bit of a mess, but let's break this down. So, firstly, I think what we can spot is that these are just inequalities we can solve, right? These sets are basically just inequalities, right? Forget the lingo again. So, if we firstly deal with A, so the set A, that's basically saying the set of values of x at 3x plus 5 is greater than 2. Well, this just work the inequality. Well, that's the only actual bit of actual information in that set. So 3x plus 5 is greater than 2. We can solve this, right, to get x. So then 3x would be greater than minus 3. X would be greater than minus 1, right? Cool. So that's A. So that's a lot here. We can work with that perhaps then. And then for B, again, it's just the inequality we need. The only bit of information there really. It's an inequality we can solve because then x over 2 plus 1 is less than or equal to 3. I could double both sides, but I'm going to move the 1 first. So x over 2 is less than or equal to 2. Then I can double to then get x is less than or equal to 4. Okay, cool. Then for C, again, this is just an inequality. It's a fancy way of dressing up an inequality. So we can just get the inequality out. So 11 less than 2x minus 1. So then I'm going to flip the sides because I want the 2x on the left, personal preference. But then 2x minus 1 is greater than 11 if I just flip the ordering. Then 2x is greater than 12, x is greater than 6. Okay, so these are the three values, right? X less than 1, x greater than minus 1, x less than or equal to 4, x greater than 6, okay? I can probably then use that, right? Because then let's have a look at this statement again, and let's see what it's really saying. So it's saying that the set A, now remember the set A just boils down to this. The set A is basically when x is greater than minus 1. That's what all that means, right? Similarly, B just means when x is less than or equal to 4. We just solved it, right? And C, again, is just the values of x greater than 6, right? So we can really simplify all this now. So what this is saying is, firstly, again with brackets, right? Let's work out what's in the bracket. So B or C, firstly, that's what that means, right? The U again means or. That means B or C. So that means x less than or equal to 4 or x greater than 6. Okay. And there we are. Okay, then it says A and. So it has to be the inequality A, the inequality for A, x greater than minus 1, and uh, some of these values. So we need to sort of say, if we write that out right, we could then say A, which is x greater than minus 1, and x less than or equal to 4, or x less than or greater than 6. I'm basically just substitute it in, right, into what this statement here is saying. I've just substituted it in with what I've worked out. Okay. Okay, well, what does that mean then? Okay. I think this is probably where it gets a bit tricky to be understand what's going on. Probably. Okay. I guess let's think about this. So basically, x has to be greater than what this is saying is x has to be greater than minus 1 no matter what. So all of these, we can basically, for each of these two inequalities, we can also apply x greater than minus 1, right? Because it has to be and. So if either one of these two inequalities is true, right? Because it's or, so it has to be at least one of them. And then if it's and this inequality, that means this inequality, we can just combine it with these two other inequalities, right? That makes any sense? So we can combine x greater than minus 1 with these in other inequalities, right? Um, and then let's see what happens then. So if we combine it, this x minus 1 with these two inequalities, that will become, well, x has to be less than or equal to 4, and x has to be greater than minus 1. Okay. So that means x has to be minus 1 is like the lower bound for x, but then x has to be at most 4. So x has to be less than or equal to 4, but x has to be above 1 minus 1. So that is the first inequality. Or and then x greater than 6, but also x has to be above minus 1. That means if x is above minus 1, but x is also above 6, well then we could just say x is above 6, right? Because if x is above 6, then by extension, x has to be above minus 1. Because, again, think about the inequality. 6 minus 1. The overlap is literally just when x is above 6, okay? And there we are. So we've actually just got a nice inequality, right? Uh, so we've complicated this absolutely confusing statement just by breaking it down step by step and really just break it down what the actual bracket's saying, right? The actual bracket's not saying anything complicated, right? It's just a simple inequality to be solved. Okay, and then once we got past this weird lingo, these symbols, well, really, it's just basic inequalities, isn't it? Really, that's what we solved, just basic inequalities. Okay, because what we did was solve x greater than minus 1 and x less than or equal to 4 first, which is this one. Then we solved x greater than minus 1 and x greater than 6, which was this one. All we've done was just solve inequalities. So we translated the set notation, the language of sets, right, into actual maths, right? That's all we've done there. Okay, so that's the solution. We can't do anything more of that. But then it's saying this solution has to be x, the set of values of x such that p is less than x less than or equal to q, or the set of values of x such that x is greater than r. If I think about it, this is saying then, again, if you just get rid of the whole lingo, just focus on the actual inequality inside the bracket. This is saying p less than x less than or equal to q, and or x is greater than r. Okay, obviously these are just numbers, right? P, Q, and R. Well, isn't that exactly um, the way our answer is laid out, isn't it? So P less than equal to X less than Q, was it? And X greater than R. Oh no, it was less than X less than equal to Q. That's exactly the same form. Hopefully you notice if I lay it out in this way, this is matching, this is mirroring our answer here is mirroring what the question's asking. So then it's asking for the values of P, Q, and R, but then we can just read it off. Therefore, simply, P has to be minus 1, Q has to be 4, and R has to be 6. Right? If we just literally mirror with our answer. And that is the answer. Okay, that's the values of P, Q, and R. Okay, cool. That is a quite hard question. That is a challenge question, but I thought that was a really good final question to really demonstrate the idea of sets. Okay, and not necessarily to freak out, just literally just work out it's actually saying. Okay, so to get rid of the whole mumbo jumbo, and just literally extract the inequality that we can solve. Okay, and then we can solve inequalities just like normal. Okay. But there we are. Okay, so I'm going to leave that there then, but I'll see you next time.